Welcome. In this lecture, we're going to return to that function, which is this polynomial, which is 2x cubed plus 9x squared plus 12x minus 1. We're going to take its second derivative to find where we want to know where is that second derivative equal to 0, where is it less than 0, and where is it greater. But this is the second derivative that we're actually looking at here. We're going to indicate all this on the number line. Okay, so over here, we're going to have this picture where we have, so here's our number line. Right, and you can think of this as being the x-axis. We actually have what's happening with f up above, and then we have what's happening with the second derivative down below. Okay, so the first thing that we need to do, so step one is just going to be to find the second derivative. Okay, so we start out with f of x equals 2x cubed plus 9x squared plus 12x minus 1. Okay, and then we want to take the derivative of that, and we're going to get, it's going to look almost the same. So now we're going to do f prime of x. It looks mildly different. Hopefully that's enough so you can see that it's actually a little bit different. So we got 3 times 2, so we get 6. We actually did this in the last lecture, but not bad to repeat it. And then x. And then we need to square it, right, because we subtract 1 from there, right? We bring down the power and then we subtract 1 from it. Here we bring down the power, so we get 9 times 2, so we get 18. And then we got to subtract 1 from 2, so that gives us 1, so x to the 1, so this is x. And then constant times x, we just finished with the constant. So now I want to take the second derivative. So this is going to equal, now again we need to multiply, right? Multiply, so bring down the power. So 6 times 2 gives me 12. And at this point I want to put the x in here in orange so that we know that when we're solving for that. And then we have x. Right, we've got 2 minus 1, so that's going to give us 1, so this is just x. Great. And then we just add, we have a constant times x, so we just write the constant, and then that constant, when you take the derivative of constant, again, you get 0. Okay, perfect. So that was step 1. So the next step, so this is our derivative, and then we're our second derivative, so now we need to figure out is for which x does this equal 0? So we want f prime of x equals 0. So we need to find those x which make that true, right? Because that's where I can possibly switch concavity. So we're going to find this. So we're just going to solve from this thing here. So I have f double prime. Listen, I don't need to write that. I've just got this here, and I got to set it equal to 0. No, let's be a little careful here in case I don't. It's good to include steps so as not to be as confusing. The more steps, the better. Sometimes we fail at that, but it's better not to. Okay, so the second derivative is equal to 0. So this is to have the second derivative is 12x plus 18. So I can just go ahead and put that in here. Wait, I'm just taking, this is telling me what to do here. So I have 12x plus 18 equals 0. Now I just need to solve for x. Okay, so now I'm going to solve for x. So I'm going to get 12x. And then I'm going to subtract 18 from both sides. So I get this is going to equal minus 18. Right, so in this step, I subtracted 18 from both sides. Right, because overall what we're doing now is we're going to be solving for x. And so now I have to divide both sides by 12. So I get equals minus 18 divided by 12. These have a common divisor of 6, so I can divide, so I get minus 3 halves. Okay, so this is my x. Okay, so I solved for x. So in this part, I'm going to solve for x. right, where I set it equal to 0. And in here, I divided both sides by 12. So here I'm dividing by 12. Okay, great. So this is like my important point. So this is the one I put on here. This is where everything kind of can change. So this is minus 3/2. Okay. And now I need to test the second derivative. Okay, so I have the second derivative of minus 2. So the second derivative, oops, my second derivative is in blue. So I have the second derivative. Oh, what did I just erase? Oh, I think I erased that I had the second derivative written here, maybe. Okay, so the second derivative of, and then let's put in a minus 2. Let's put that value in red because this is like such an important, this is the possible inflection point. So what can happen here? So I have my second derivative. If I put that into, right, for the second derivative, I put it into this function. Okay, so let's just, this is equal to, and what does that end up equaling? It equals 12 parentheses plus 18. So I put in the minus 2, right? So I get minus 24 plus 18, and that should equal minus 6, okay, which is less than 0. Okay, so when it's less than 0, what does that tell me? It tells me that my graph is actually concave down, right? So, right, this is concave down. Since this f double prime is less than 0, since my second derivative was less than 0. And then over here, I can do another test value. So I'm going to put, so I take the second derivative of, and then let's try this at 0. Okay, so this is going to equal, so I have 12 times, right now I put this in, so this is 12 times 0 plus 18, so this is just equal to 18, which is greater than 0. So that gives me concave up since this second derivative is greater than 0, right? And because I switched from concave down to concave up, I'm going to have an inflection point here, right? So I have an inflection point here. Okay, so I was able to actually, I took my two derivatives to get the second derivative. I looked for, I solved for where the second derivative was 0 to see where the concavity might switch. So I just solved for x in here, and I found x equals minus 3/2, right, where I'd set this second derivative equal to 0. And then I was able to then say, okay, so something might happen at minus 3/2, but on this side and this side, the concavity is not going to switch. To figure out, I just used a test point, so I took a value less than minus 3/2, like minus 2. I stuck it into my second derivative. I got that my second derivative was negative or less than 0, which meant that this was concave down. On this side, I took a test point that was greater than minus 3/2. And this, so I took 0, I put that into my second derivative. I got something that was greater than 0, which told me that this was concave up. Okay, and because I switched concavities, I knew that I had an inflection point there. Okay, so I hope that made some sense, and I will see you in the next lecture.